right, welcome back. We've got day 5 here, chemical reactions. Your goal today, you know that we get energy from food. So what does that mean exactly? What's happening inside our bodies? By the end of the period, you should have answers in your doodle sheet just for R. You're going to be watching a video, Science with Skold, and you're going to need the Burning Food Lab Sheet. Place page 2 and page 3 in your notebook following the Calorie King. And then you're going to be burning some food. All right, how do we get the energy from food? So that's our main question here. Here you have 3 pictures. We got that top picture, all those fruits and vegetables. We've got the second picture, those meats. And we've got that third picture, you've got oil and butter. So those are our components of food, right? The top picture represents carbohydrates. The second picture represents your proteins. And the third picture represents your fats or lipids. So we take that stuff and we turn it into energy for ourselves. So what's going on? An analogy would be like, how does a car get energy from fuel, right? So you got the tank, or sorry, you have the pump, and with the pump, you've got the gas there, and you put it into your car, and your car basically, with the gas plus air and some electricity, it combusts that gas, and that causes your car to go. Well, what are we going to be calling that matter transformation here? I already said it. Combustion. Okay, so food is essentially our fuel. So we talk about burning calories, we talk about burning carbs and burning fat, but we're still trying to figure out, how do we get energy from food? Well, here's your clue. We burn it. So now go and read the lab instructions for our burning food lab. Read through the whole lab, then return to this video, and you'll move on. Okay, so now that you've read the lab, we're ready to move on. If you haven't, please put it on pause. So now you're going to see a video with Mr. Skold. Keep in mind the volume is a little low.
Welcome everyone to Science with Skold. Today we are going to be finding out how many calories are in a cheeto through measuring the amount of energy that is generated by burning a cheeto. How are we going to do this? Well, we're going to light it on fire. We're going to see how much heat gets transferred into water. All right. So first thing we'll need to do is throw on our safety goggles. And if we come over here, you can see that I have my my setup ready to go. I have a thermometer here that's going to be measuring the water that's going to be being heated in this aluminum can. The reason we chose aluminum is so that the heat can go into the water easier. Now, I am trying to keep the thermometer off the bottom of the tin can, but if you can't do that, that's okay. The main purpose of it just being held here is so that it doesn't fall on the floor. We have a glass petri dish that we're going to be burning our Cheeto in, and we have a little Cheeto stand. Let's get that set up. Now, when you go through, you're going to want to find out your perfect Cheeto to use. This looks like the one that I'm going to choose for today. We'll put it right on our little stand. Just spin it. You know it's ready to go. All right. We'll put that right on there and then try to get that right below. The reason why I placed the Cheeto so close to the bottom of the can is because we want as much of the energy from the Cheeto going into the water. Now, you're going to need to measure out about 100 milliliters of water. Find that, do the measurements on the side of these beakers. When you're ready, you'll add your water into your can. We'll want to give it a minute so that we can actually measure the temperature of the water before we start the experiment. All right, so while we're waiting for our temperature to be recorded for the water, we're going to weigh our Cheeto and its apparatus. So to do that, you're going to want to turn on your scale, make sure it's all zeroed out and ready to go. And looks like we'll want it to there. There we go. It's ready. So we'll measure this, and you'll want to record this right where Miss Hambrick says in your notebooks. Okay, it looks like we're starting with 34.6 grams today. All right, I put that under here, and now we'll want to record our temperature. We're going to want Celsius. It's going to be about 17 degrees for us. Just a couple lines above the 15-degree mark. Careful not to record Fahrenheit. calories are measured using Celsius in the equation. Okay. When you're ready to begin, be sure to get your teacher's permission. Okay? You'll be either lighting it under her supervision, or she might be doing the lighting of the Cheeto herself. Either way, we still get to watch the sucker burn. All right. So when we're ready to begin, we're going to light it on fire. And remember, you're going to want to look for any color changes, matter that comes off of the Cheeto, and also how quickly the temperature rises. The main thing that we will be recording is the change in temperature. We're going to want that maximum temperature change. So be sure to get it before it starts to cool down. Remember, we started at 17 degrees Celsius. Some Cheetos may light easier than others. Wow, look at it go. Now, as it burns, notice there's matter that's being given off. This might be something to take into consideration when we talk about errors for this experiment. For chemical reactions, we have a huge color change. And we also have a lot of black smoke being given off. Wow, how cool. It's amazing, but we could already see a temperature change. It looks like it's just about 20 degrees. Be careful not to get that measurement too early. It may still continue to rise after the Cheeto burns out.
Okay, so there's your demo. Now, think about what you saw in Mr. Skold's video. What happens with the matter? How does it transform? What are the inputs and outputs? What's going on with energy? What evidence do you see of energy? Go ahead and record your observations in Doodlebox R. Also, if you have any questions, write them into Doodlebox R as well. All right, go ahead and put this on pause, and then we'll continue on. All right, now it's your turn. Get the materials, get everything set up like you saw in the video, and it states in your lab, and then the only thing is just wait for me before you actually burn your Cheeto. So you can burn it, but I'm going to come over to you and watch it happen. All right, so go ahead and put me on pause and get your materials set up. Okay, welcome back. Pretty cool. So burning our fuel, our food, is a lot like burning fuel, right? Except that it's a lot messier for right now. So there's a lot of different ingredients in a Cheeto. It's a mixture of things. So there's more here than just a pure fuel made of carbon, hydrogen, and oxygen. So let's think about that piece. Here are things that are in a Cheeto. You had seen them written on your worksheet, but here you can see some representations of these molecules. So you can see your sugars up at the top right. You can see the riboflavin, what that looks like, what it's composed of, niacin, folic acid, flavor enhancers, all of these different things. So keep in mind these complex nature of Cheetos makes it also interesting. You know, how do we get energy from food in a simpler system? So keep those things in mind. Make sure that you get your worksheets 100% filled out and done, and leave your notebooks for me at the back. I'd like to see what you have. If you were able to figure out those equations and get everything done, that's awesome. If not, I will be reviewing them with you on Monday. But I want you to try it first to see if you can figure it out. Okay, that's it for today, and I will see you Monday when we look at the molecular nature of food.